Alright, in this video here we're going to be talking about exponential notation. Alright, so what exponential notation looks like and what it represents. So if a is any real number and n is a positive integer, right? Remember, integers are the positive and negative whole numbers. So we're saying here this number n has to be a positive integer, so basically just the positive whole numbers. Well, then the definition of a raised to the n power, right? The a with that n as like a little superscript up above it, right? A to the nth power equals a times a times a times a n times, right? So what an exponent represents is repeated multiplication, right? Taking this number that we call the base, right? A is what we call the base. That's the number that's down below. N is called the exponent, the number that's up a little bit higher, right? So when we have a base raised to a power, it means we are taking that base number and multiplying that base number times itself n number of times. Whatever that exponent is, that's how many times we're multiplying that base number times itself, right? So basically what an exponent is a shorthand notation for repeated multiplication, just multiplying the same number times itself a certain number of times. All right, so that's what exponential notation looks like. That's what it means. And here just a couple quick examples of putting things in exponential notation, right? So example A here, I have 1/2 to the 5th power. All right, remember, a, the base, can be any real number. Positive number, negative number, fraction, decimal, it doesn't matter, right? Any real number, we can apply an exponent to it. So 1/2 to the 5th power means I'm taking that base number of 1/2 and I'm multiplying 1/2 times itself 5 times, right? Because my exponent is 5, that tells me how many times to multiply this 1/2. All right, so it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2. I think I said that 5 times. Right, so now we're multiplying all these fractions. So if you haven't watched the videos I did yet about fractions, I did one about multiplying fractions. And when you multiply fractions, you just multiply the numerators together. So even if I have 5 fractions multiplied, I just multiply all 5 numerators. So 1 times 1 times 1 times 1 times 1. Well, it doesn't matter how many times I multiply 1 times itself. That's always just going to equal 1. All right, so it's going to be 1 over, and then 2 times 2 times 2 times 2 times 2. All right, so 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is going to be 32. All right, so 1/2 to the 5th power is 1/32, or 1 over 32. All right, so I take the 1/2, multiply it by itself 5 times. That's what an exponent means. Now, it doesn't matter what number here you have as the base, you multiply that number times itself, whatever that exponent says there, that's how many times you multiply it. All right, and for fractions, you just multiply the numerators, you multiply the denominators. All right, part B, or example B, -3 in parentheses raised to the 4th power. Right, so notice examples B and C here look pretty similar, right? They both say -3 to the 4th power. Example B, though, has that -3 in parentheses with that 4th power outside of the parentheses. Example C does not have any parentheses at all. All right, so again, paying attention to the details, the notations that are there or aren't there, change the meaning of what you're looking at, right? These two, even though they look very similar, they're going to have 2 different answers because one of them has those parentheses and the other one doesn't. All right, so how that comes about, or how we get those 2 different answers, right? For part B, the -3 is in parentheses being raised to the 4th power. If that 4th power is outside of the parentheses, that means everything inside that parentheses is included and being raised to that power. Right, so in other words, in this case, we have -3 multiplied by itself 4 times. Right, that negative and that 3 are both in the parentheses. Both of those are grouped together, being raised to the 4th power. So when I multiply it out, I put a -3 in each one of those parentheses. All right, and then if I multiply -3 times itself 4 times, let's see what we get. All right, so -3 times -3 is going to be +9. Positive 9 times -3 is going to be -27, and then -27 times -3 is going to be +81. Right, so -3 in parentheses raised to the 4th power equals +81. Right, since I'm multiplying an even number of negatives here, right, 4 negatives, each pair of negatives, each 2 is going to cancel out and become a positive. So if I have an even number of negatives, like a 4th power here, the answer comes out being positive. All right. So that's -3 in parentheses raised to the 4th power. For -3 to the 4th power, not in parentheses, it's a little bit different, right? Here, that 4th power is only attached to the 3. That negative is not being included, not being raised to that 4th power. If we want to include that negative and also raise that negative to the 4th power, we have to put parentheses around the -3 like we had up here in example B. All right, so this negative 3 to the 4th power means negative, and then we're raising 3 to the 4th power. Right, so the exponent only applies to the thing that it's attached to. Right here, the 4, let me get a different color here. Right, the 4 exponent is only attached to that base number of 3. It's not being attached to that negative. Right here, since that negative 3 is in the parentheses and the 4 is attached to the parentheses, that means that 4 applies to everything within the parentheses. Right? Hopefully you can distinguish that and see the difference between those two, because it is an important difference. As we see here, if I multiply 3 times 3 times 3 times 3, kind of like what I did up here, I'm going to get 81. But since I had that negative out in front of all this stuff, the answer here is going to be a negative 81. Right? I don't multiply that negative with the 3 all 4 times. I just have the one negative out front, and then the 3 being multiplied 4 times. So I end up with a negative 81 here. Whereas when I had in example B, the negative 3 in parentheses to the 4th power, since I'm multiplying that negative with the 3 each time, now I come out to a positive 81. Right? So again, paying attention to those little details. Is there parentheses there? Is there not parentheses there? Understanding those little rules of mathematics is very important to doing something like this correctly. And when you're dealing with exponents, the key thing with exponents is the exponent only applies to whatever it's attached to. If the exponent is attached to a parentheses, that means it applies to that entire parentheses, everything within, like example B. If there's no parentheses, then that exponent is only attached to that number that it's above. In this case, it's only attached to the 3, not to the negative. All right, so that is a little bit about exponential notation and a couple examples of that.